There are over 2 million procedures performed worldwide every year that involve bone grafting. Everything from cancer to trauma and congenital defects. There's no other way to say it. If you need a piece of human bone, the only way to get it is to cut it out of a human. We're hoping to disrupt that process and view the body as a renewable resource of cells that we can use to grow bones from scratch.
In the past 10 years, the field of tissue engineering has exploded. Labs are growing everything from clusters of beating heart cells to functioning human tracheas. But growing a bone? That's an entirely more difficult challenge. Epibone, a Harlem startup founded by two former researchers at Columbia University, are aiming to do just that.
Can you explain to me what the need for this new kind of technology is? Why would somebody need a bone made out of something else rather than from their own body?
So right now, if people need bone replacements, they might either get a cadaver bone or a synthetic implant, or cut a piece of bone out of yourself. So that's called autograft. An autograft requires you to have a second surgery. That might be more painful than the actual surgery that that piece of bone is meant to replace. We think that Epibone has the potential to be better because it's an anatomical shape. There's a perfect fit. And because it's alive, it can continue to remodel and grow with the patient. What we're really proposing is a different view of the body, to view it as a renewable resource of stem cells that can regenerate new parts as you need them.
Tissue engineers can grow stem cells into almost any type of human tissue, but simply having some stem cells doesn't mean you can grow a bone in a petri dish. You need some other things.
So regenerative medicine kind of relies on three things: stem cells, scaffolds, and bioreactors. You need to have the right stem cell source, right? And so we got that. And then we need to put those cells into something that help them understand how to differentiate.
What to become.
What to become, exactly. In our case, we're using a bone tissue from a cow that's stripped of all of its cellular material, but the nanostructure contains information that speaks to those stem cells and encourages them to move down the bone differentiation pathway.
Before that cow bone or scaffold can be infused with the patient's own stem cells, it needs to be the right size and shape. For that, Epibone takes a CT scan of the patient to get a 3D model of where the bone will wind up. The donor bone is then milled into shape, and stem cells are added to it. The bone and the stem cells grow together inside a specially made container called a bioreactor, which is basically a jumbo petri dish that can mimic the conditions found in the human body.
You got to keep it sterile, you got to keep it moist, and you have to keep it fed. That's why it's perfectly housed in here. This is a silicone material that is perfectly matched to the shape and shunts the fluid that feeds the cells evenly through the scaffolding.
The entire process, from harvesting the stem cells to incubating the bone in the bioreactor, takes about 5 weeks.
So between the cells, the scaffold, and now the bioreactor for those two things to grow together, over time, you wind up with
a piece of mature, living human bone that's hopefully ready for implantation.
Epibone has successfully implanted bones in pigs. While the FDA has not yet approved trials on humans, they're not far off.
We're hoping to do our first in-human implantations early next year, but we're working towards bona fide clinical trials to begin within the next 3 years. We hope that with our company that we can help people live better lives. We really want to see ourselves as part of a story of rethinking the way we repair the body and collaborating with what nature's given us already to come up with natural alternatives.